In the previous lesson, we looked at using flexbox to achieve this 3-column layout that fills all available space and responds to the viewport size without using any hard-coded values for widths or heights. This layout looks great at medium to large device sizes, but on a smaller mobile device, not all the content is visible. To make the content respond automatically on smaller screen sizes, we can use 2 flex properties, flex wrap and flex basis. First, on the flex container, which is this section element here, click the flex wrap button and choose wrap. You'll now see the boxes stack on top of each other, which looks like the flex direction has been set to column. Just to confirm, the flex direction is still row, but now we need to apply the flex basis property to the flex items. Select one of the child elements and find the flex basis input. The flex basis property sets the initial main size of a flex item before any flex grow or flex shrink adjustments are made. It accepts length values such as 200 pixels, percentages, or CSS keywords. Flex basis is used to set the ideal size of the element, for example 200 pixels. When you apply that flex basis value to all flex items in combination with flex grow and flex shrink that we covered in the previous lesson, all items will be automatically distributed in the viewport depending on available space. Whilst we've solved the issue of the content looking cramped on small screens, we've now got an issue on larger screens where the content stretches out a bit too much, making it difficult to read. In these cases, it's always useful to add a max width to the parent container. For example, in this case, we can select the section element, find the size section in the style panel, and add a max width of, say, 1080 pixels. We can also go one step further. In the previous lesson, we added a gap of 16 pixels to the flex container to automatically add space between the flex items. And this currently stays constant as you resize the viewport. To level this up, we can use the CSS clamp function to make the gap between the cards expand and contract depending on the screen size, making the layout even more fluid. CSS functions are special built-in tools in CSS that let you calculate values, transform elements, apply colors, load images, and more instead of only writing fixed values. For example, you can use the calc function to calculate more dynamic values such as widths and heights. CSS functions are written as the function name followed by an opening bracket, the input to the function, and a closing bracket. For example, you could use the calc function to calculate the height of the main content of a page in relation to the height of a header by using height equals calc 100vh minus 80 pixels, where 80 pixels is the height of the header and 100vh is the full height of the viewport. The clamp function in CSS allows you to create values that scale responsively between a minimum and maximum limit. It accepts 3 values. The first value is the smallest allowed size. The second value is the ideal flexible size. And the third value is the largest allowed size. I'm going to demonstrate this using some extreme values so you can see more clearly what's going on. On the gap property, we can add the clamp function by typing clamp and an opening bracket, add a first value of 16 pixels, a comma, a second value of 6VW, and more on the VW unit in a moment, another comma, and a third value of 100 pixels. Finish off with a closing bracket. This means the gap size will never become smaller than 16 pixels. It will try to scale relative to the viewport width using 6VW, and it will never become larger than 100 pixels. Using the clamp function, the browser automatically calculates the value depending on the available space on the screen, making it really useful for responsive design because elements can scale fluidly without needing media queries for different viewport sizes. And we'll take a look at using clamp more in the next lesson on fluid typography. An important thing to note is that clamp is not responsive by itself, and it depends on the middle value being flexible in order for the size to scale. If you use pixel units in the second value, it won't respond accordingly. So let's dive deeper into that second value in the clamp function, where we used the VW or viewport width unit, which is a flexible unit. If you've come from a design background, you may be familiar with using pixels to represent units in designs. We can definitely use pixels in CSS, but pixels are absolute units and stay fixed regardless of screen size, so they're not that useful in creating responsive and fluid designs. The good news is that CSS comes with a whole host of other relative unit values that are designed to respond to different viewports and screen sizes. And the other bit of good news is that you get access to all of these relative CSS units in the Style panel. Wherever you can add a numerical value in the Style panel, such as in the Size section, you can add some numbers and you'll see a drop-down showing all of the available CSS units. Now let's see how some of these units work in practice. On this page, I have 3 elements, each demonstrating a relative unit. The yellow box has a width of 75%, meaning it takes up 75% of its parent container's width. If I change the size of the viewport, you'll see the yellow box expand and contract to remain at 75% of the parent container width. This blue box is using the viewport width or VW unit. With VW, values are calculated as a percentage of the viewport width, where 1 VW is equal to 1% of the viewport width. This box is set to 50 VW, meaning that when the viewport is expanded and contracted, it always spans 50% of the viewport width and not the parent container width. Finally, the pink box is using the viewport height unit, or VH. It works in the same way as VW, but uses the height of the viewport to calculate its size. This box is set to 20 VH, meaning its height will always be 20% of the visible viewport. There are many more relative CSS units to explore, including those specific to mobile viewport device sizes, such as DVW and DVH, which relate to the dynamic size of mobile viewports to account for the presence of mobile browser address bars, for example. So why not explore the units in the Style panel to get a feel for your options? As ever, the best way to learn is to experiment and explore. And an added bonus of using relative units is that you rarely need to use media queries to apply different CSS styles for different screen sizes. You'll also notice that when I resized this viewport, the page title scaled with the viewport size as it was styled using the VW unit. And this is a great segue into the next lesson in this module.